Hello class, welcome back to my YouTube channel, and today this is the start of our discussion for the statistics and probability. So for today's lesson, we are going to have our lesson 1, which is all about the random variables. So let us have our objectives for today's discussion. The learner will be able to first illustrate a random variable. So since our topic is a random variable. Second, distinguish between a discrete and a continuous random variable. And lastly, find the values of a random variable. So now, to start off, let us define the term statistics, since this is our subject. The topic revolves to statistics. This is a branch of science that deals with the collection, analysis, interpretation, and presentation of the data. So it just simply means that the statistics is a science that studies data. So this data were used to find an answer or somehow a solution to a certain problem or an inquiry. So there are experiments or there are observable occurrences in those data, that the statistics from those data were used in decision making. So we have statistics. There is a tool that, or a topic that always relates to statistics, and that is a probability. So this probability is a mathematical tool used to study randomness. So randomness meaning we are just getting values or random numbers from a certain data. It deals with the chance of an event occurring, or we are referring to the likelihood that this thing will happen or this outcome will happen. So these are the probabilities. So we can just simply said that the probability is a possibility. So it deals with the occurrence of a certain random event. So later we are going to discuss the different properties of probability. So we have discussed the statistics. So there is called a statistical experiment. So what is this? This is any process by which observations or any occurrences by which we have observed, or the observations are made, and from those observations the data is gathered or collected. So we have somehow a study or experiment wherein we observe and then there is an outcome, so we get or collect the data. So I've said outcome. What is this outcome? So the outcome is the result of our statistical or our experiment, an experiment. Sample space. So what do we mean by sample space? So we refer to the sample space as the collection of all possible outcomes of the occurrences or the experiment. So it is denoted by capital S. Now we're now going to our topic. So but first, let us have examples of certain events or certain statistical experiments that were used for studies. So first example, we have tossing a coin. So we know that tossing a coin were used as a game or somehow for decision making. Let's say you and your friend are arguing and trying to come up with a certain decision, and you decided to toss a coin by which of two which of the by which an outcome will refer to that you will do something or not. So in tossing a coin, your coin has a head and a tail. So these are the tails, and the head and the tails are the two possible outcomes when we toss a coin or the coin. So we have 50%. So what is this? Where this 50% came from? So the 50% came from the probability or the chance that we can get a head and or a tail. So or a tail. So we can get a head or we can get a tail. So we have 1 as your head over 2, which you have 2 possible outcomes. For the tail, you have 1 tail over 2 possible outcomes, the head and the tail. So our sample space here is equals to H, T. H for head and T for tail. Let's have another example experiment. So we have rolling a die. So rolling a die, also we're familiar with a board game, Snakes and Ladders. So by that we roll a die, then the die, which is a cube with 6 sides, has 6 faces with different dots. So these dots are this. So we have 1 face with 1 dots, 2, 3, 4, 5, and 6. So if we are going to reminisce our time when we play a snake and ladder, so when we get 1, we just move with 1 step, so and so on. So these are the possible outcomes of rolling a die. So since we have 6 faces of a cube or a die, so we have the sample space 1, 2, 3, 4, 5, and 6. And last experiment example we have is this problem. So a person is chosen at a random for an experiment, and the sex of the person is recorded. So since we are just getting random persons, we just get to know them, then record their sexes. So we have 2 possible outcomes. Those are the male and female. Now let us move to random variables. So we are dealing with the statistics. What do we mean? Why do we have random variables? So this random variable came from a data. So a set of data, So a variable whose value, so the data can be represented with a variable. So meaning it's varying. So this variable has values. So those values is determined by the outcome of the experiment wherein we are getting a data. And possible outcomes of a random procedure or experiment. So we've already discussed the statistical experiment, the outcomes, and the sample space. So we know now the outcomes from a statistical experiment or just a random procedure. So we represent that, the values that we are getting, with a random variable. So simply, it can be noted just as capital X, Y, Z, and so on, or other variables. So let's have examples. Example problem for random variable. So in here, a salesperson has 3 tables left in the store to sell. So we want to know how many tables will be sold in the next 5 days. So the researchers will be we're going to observe in the next 5 days if there are tables or how many tables will be solved in those 5 days, in the next coming 5 days. So since there are only 3 tables left to be solved, so it is possible that there are no tables will be solved in a day. It is also possible that 1, 2, or all 3 tables will be solved in the next 5 days. So the value for our the random variable we have here, so we represent it by x, is the number of tables that will be solved in the next 5 days. So this random variable x, or the number of values, the number of the values for the tables to be solved are 0, so no tables will be solved in the next 5 days, 1, 2, and up to 3, since there are 3 tables left. So this is our random variable x, which represents the tables left, the tables to be solved in that store. So that is an example of random variable. So the random variable has 2 classifications. So what are those? The discrete random variable and the continuous random variable. So we are going to discuss the 2. First, discrete random variables. So what are these? So these are random variables that can take on a finite. So meaning we have a certain number, finite only. Or it can be countable, infinite. So you have infinite number, but it can be counted of distinct values. This is the discrete random variables. So let's have an example to further understand. So again, the discrete random variables are the values or the outcomes that can be counted. And also, the discrete random variable, so that values we have can be described by an integer value, or just simply a number. So example, we have here a study on the number of customers served by a restaurant on a particular day was conducted. If the random variable x denotes or represents the number of customers served on that day, then x can take one of the values from this random variable x, which is equals to 0, 1, 2, 3, and 4. So how did those researchers get that? So they observed that in the restaurant, how many numbers will go and dine there. So there are possibilities that it can have 0 customers, 1, 2, 3, and 4. So this random variable, the number of customers served by the restaurant, yung x, the x, has a value which can be counted. So we have 0, 1, 2, and 3. That is why this is an example of a discrete random variable. So other examples of discrete random variable are the number of deaths we have, unfortunately, due to this COVID-19 pandemic. Also, another example is the number of students we have in our school, in Bagong Barrio Senior High School. Even though it's we are in trying time, we are in these difficult times, there are a lot of students who enroll. So the number of students is an example of a discrete random variable. So the other classification is the continuous random variable. So this is the last part of our discussion for the lesson 1. So this continuous random variable are the random variables that take an uncountably, meaning it cannot be counted, infinite numbers of possible values. So there are lots of outcomes that cannot be counted. Typically, these random variable these quantities are the measurable quantities. So this is the clue term for continuous. This can be measured. So let's have example. Suppose we are interested in looking at statistics test scores from a sample of 40 students. So the random variable here would be the test scores, which would range, so the values will range from 0% to 100%. So in this case, we are using intervals to denote the various values of the random variable. Meaning, since it has an interval, it cannot be counted, or it's just we can just measure the test scores. So this is an example of a continuous random variable. Another example is the weight of the newborn babies, and also the amount of paint needed for a certain canvas or a certain project. So the amount of paint cannot be counted. So it can be measured, like say for example 1 liter, 2 liters. For the weight of the newborn babies, it can be measured in kilograms or in grams or in pounds, and so on. So those are the random variables. How can we distinguish the two? Classification of random variables, the discrete and the continuous, and lastly, how we find the possible values of a random variable. Of course, we are going to look at the experiment and observe to collect the data. That's it for our lesson 1.